Hi everyone, welcome to our manual testing series. In this series, we'll cover the most important testing concepts, real world examples, and common interview questions to help you boost your QA career. Now, let's begin our first session with a few basic concepts. What is software manual testing? Manual testing is the process of testing software applications manually without using automated tools. Testers act as end users to identify bugs and ensure the software meets its requirements. It is one of the earliest forms of software testing and remains relevant even today. Manual testing also provides valuable insights into the software's usability, functionality, and overall user experience. When should manual testing be used? Manual testing is suitable for small applications with fewer features as it is cost effective. It is also essential when new features are introduced to ensure they behave as expected before automating the tests. Manual testing is particularly useful for exploratory testing, where testers use their intuition to find issues that automated scripts may miss. Additionally, it is ideal for testing the user interface, ensuring the GUI is user friendly and functions correctly. What are the different types of software testing? Software testing can be broadly classified into several types. Manual testing is done manually without using automation tools. Automation testing uses scripts and tools to perform repetitive tests efficiently. Functional testing ensures the software works according to specified requirements, while non functional testing checks performance, usability, reliability, and security. Unit testing focuses on individual modules. Integration testing ensures modules work together. System testing tests the complete system, and acceptance testing verifies that the software meets business requirements and is ready for production. What is verification in software testing? Verification is the process of ensuring that the software is built correctly. It answers the question, are we building the product right? And is performed by developers, testers, and project managers through reviews, inspections, and code analysis during the development phase. Its purpose is to prevent defects early and ensure adherence to requirements. What is validation in software testing? Validation ensures that the software meets the user's needs. It answers the question, are we building the right product? And is performed by testers, users, and stakeholders through functional testing and user acceptance testing after the development phase. Its purpose is to ensure that the software meets business requirements. And this is the difference between verification and validation in software testing. Tabular view for better understanding. Let's look at the different types of applications in software testing. Each application type has its own characteristics, testing requirements, and methods. Web applications are tested for functionality, compatibility, performance, and security. Mobile applications focus on usability, compatibility, performance, and security. Desktop applications require testing for functionality, compatibility, performance, and installation. Cloud applications need scalability, security, performance, and compatibility testing. Enterprise applications focus on integration, functionality, performance, and security. Embedded applications emphasize real time performance, reliability, and safety. Game applications are tested for game mechanics, performance, usability, and security. API applications focus on endpoint functionality, security, and performance. SaaS applications are tested for functionality, security, performance, and load handling. Finally, client server applications require testing for server load, communication, security, and integration. And in the case of AI and machine learning applications, testing ensures algorithm accuracy, performance, and security. These are some of the most common application types in software testing, each requiring a specialized approach. Now, move on to the next question. What are the probabilities of getting an error in any application? When testing any application, the probability of errors depends on multiple factors. For simple applications, if requirements are clear and testing is thorough, the error probability is usually low, around 10 to 20%. For complex applications where requirements may not be well defined or testing is incomplete, the error probability can rise much higher, even 30 to 50% or more. Several factors influence these probabilities. Complexity of the application. The more complex the system, the greater the chance of defects. Size of the application. Larger applications with more code and features naturally carry a higher risk. Quality of requirements and design. Ambiguous or poorly defined requirements increase defects, while clear documentation reduces them. Testing coverage. Low coverage may miss critical errors, but thorough coverage across different scenarios reduces risk. Types of testing performed. Using multiple approaches like functional, exploratory, and regression testing helps uncover hidden issues. Testers' experience and skill level. Skilled testers are more likely to detect defects, while inexperienced testers may overlook them. Test environment. Unstable or varied environments add risk, whereas stable environments reduce environment-related errors. In short, error probability is not fixed. It depends on complexity, quality of requirements, test coverage, tester skills, and the environment. This table makes it clear how each factor contributes to the overall probability of errors. What are the types of manual testing? Now let's look at the different types of manual testing. Functional testing, this ensures the software works as per the functional requirements. It includes unit testing, integration testing, system testing, and acceptance testing. Non-functional testing. Here, we check aspects beyond functionality, like performance, usability, security, and compatibility. These tests focus on how well the system performs. Regression testing. After code changes, we rerun previously passed test cases to make sure nothing is broken. This helps confirm that new features or fixes don't create new bugs. Exploratory testing. In this type, the tester explores the application freely without predefined test cases. It's useful for discovering unexpected issues through ad hoc navigation. Smoke testing. This is a quick round of testing to check if the basic functions are working after a new build. For example, verifying login, navigation, or other critical features. Sanity testing, a narrow and deep testing approach done after small code changes or bug fixes to ensure that the specific functionality works as expected without breaking related areas. For example, if a bug was fixed in the payment module, sanity testing verifies that the payment flow works correctly. Ad hoc testing. This is unstructured testing performed without formal test cases. Testers rely on their intuition and experience to uncover defects. Together, these types of manual testing help ensure both functionality and quality of the application before release. Now, let's continue with more types of manual testing. Alpha testing. This is the initial round of testing performed in-house by the development or QA team before releasing the product. It helps catch early defects. Beta testing. After alpha testing, the software is released to a limited group of real users in a real-world environment. Their feedback helps identify issues that may not appear in internal testing. User interface UI testing. This verifies that the software's user interface looks and works as expected. It checks layout, responsiveness, and consistency with design standards. Negative testing. Here, we provide invalid or unexpected inputs to ensure the system handles errors gracefully. For example, entering letters in numeric fields. Positive testing. In contrast, this ensures that the system behaves correctly with valid inputs. For instance, logging in with correct credentials. End-to-end testing. Finally, this type validates the entire workflow of the system from start to finish, ensuring that all components work together smoothly. With these, we complete the major types of manual testing that every QA should know. These were a few important manual testing questions we covered in this session. We'll be covering more in the next session. For any queries, please contact us at the email address mentioned here. Thank you for watching. Please don't forget to like, share, and subscribe. Follow for more updates.